Let's take a look at the practice quiz for Standard 6 on solving polynomials. So in the first question, we're going to use this function that's at the top to answer several questions on this first page. So it asked me to identify the following and write them as order pairs, the relative min and the relative max. And if there's more than one, we'll write all of them accordingly. So let's type it into Desmos and take a look. So x cubed minus 5x plus 12. We have a relative maximum point at negative 1.3, I'm just going to round that off, and 16.3. So let's write that down. Negative 1.3, 16.3. So make sure you put that in the right spot. That's a relative maximum. And then we have a relative minimum point that's located at 1.3, and let's just say 7.7. You don't have to round them off. You're welcome to write that all out, but I'm just going to round them off for this video. It says, describe the end behavior of the graph. So I see that the graph looks like this shape, and I can tell it's headed toward the first quadrant on one end of the graph, where everything is positive. So as x approaches positive infinity, y approaches positive infinity. That needs to go in the second blank. And then on this end of the graph, it's headed toward the third quadrant, where x is negative and y is negative. So it would be appropriate to put where x approaches negative infinity, y, which they just wrote as f of x, also approaches negative infinity. All right, I'm going to move that out of the way now and do the next part. So it says find all the roots of f of x. So if we look at our graph, and this is just still using that same function at the top of our page, let's write that out. So for f of x equals x cubed, I notice there's no squared term, so I'm going to put in 0x squared minus 5x plus 12. And I can see that I have a root at negative 3. So let's start with negative 3 in the box for synthetic division, and let's write out the coefficients of our polynomial. So we have a 1, we have a 0, we have a negative 5, and a positive 12. So let's write 1, 0, that's really important to remember the 0, negative 5, and 12. Then bring down the 1 to get started. Then we're going to say 1 times negative 3, that would just be negative 3, and then write it underneath the second number. Then add those together, so 0 plus negative 3 is negative 3. Multiply negative 3 by negative 3, we get 9. And then add negative 5 plus 9, and we get 4. And then 4 times negative 3 is negative 12. And we add those together, and we get 0. And we should get 0 because we know that x plus 3 is a factor, and that this is a root of our polynomial. So that's kind of a checkpoint for your problem that you should have no remainder. Now we need to continue on to figure out the rest of the roots, because we only have one real root. That means there are going to be 2 imaginary or complex roots. They mean the same thing. So we've got to use the quadratic formula. Remember, x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a is our formula. Now let's plug in negative. Let me pick these out. So a equals 1. B equals negative 3, and C equals 4. Those are the numbers I'm going to plug in. So negative B would be negative negative 3 plus or minus the square root of negative 3 squared minus 4 times A, which was 1, and C, which is 4. Then all divided by 2 times A, which again is just 1. Now we're going to clean that up. So I'm going to type in everything underneath the radical, but don't type the square root, just those numbers underneath. All right, so using parentheses to make sure your numbers come out right, let's put in parentheses negative 3 squared minus 4 times 1 times 4. And we end up with negative 7. So let's rewrite the function with our negative 7 filled in. So x equals positive 3, because negative negative turns into a positive 3, plus or minus the square root of negative 7, all divided by 2. Now the negative underneath we could help a little bit, but 7 won't come out evenly. We can rewrite the square root of negative 7 as the square root of negative 1 times the square root of 7. So then I'm going to bring it over here where I got some more room to write. So we can say 3 plus or minus, then rewrite the square root of negative 1 so it's just I. But the square root of 7 does not come out evenly, so you just have to leave it there. Now, those are our imaginary or complex roots. So they would go in this blank right here, or you can just draw an arrow to that blank. And then our real roots, that's what we started with, was the negative 3. So you would just put that in that blank or indicate that that is your real root. And so we have found all 3 roots that we needed. Remember, we had 3 that we were looking for because our highest exponent was 3, or in other words, this is a cubic function. Number 4 says write out the factored form of f of x. All right, so all we have to do for this, it's very simple, is write the factors. So x plus 3 goes with that real root we wrote, which was negative 3. And then notice these are imaginary roots, so don't use those to write your other factors. Just use this quadratic form that we have right here. So remember, when we fill back in our variables, we start with 1 less power than what the original polynomial we divided into had. So it was x cubed. Now our quotient is x squared minus 3x plus 4. And then that is your other factor that you just write for factored form. And that's it. Now, to check and make sure that you have the right answer, you can type it in Desmos. So I'm just going to type the original one. So x cubed minus 5x plus 12. Then notice when I type in factored form, it should match. So x plus 3, and then x squared minus 3x plus 4. And notice they line up. Like if I take that away and put it back, they line up. They coincide, in other words. So you can turn them off and on and see that they match. And that's all you have to write for number 4. There's no other work involved. Number 5 says write a polynomial in factored form that has roots negative 3 and 5 and a double root at 2 and a y-intercept of 0, negative 2. So let's write out factored form would be y equals, we're given the y-intercept, so we have enough information to find a. So put a out front, and then let's use our roots to write the factors. So if we have a root at negative 3, our factor is x plus 3. We have a root at 5, so our factor is x minus 5. Remember to change the sign. Then we have a double root at 2, so that would be x minus 2 squared. Then using the y-intercept of 0, negative 2, we're going to plug in 0 for x and negative 2 for y, because that's what that means. And we can use those numbers to help us figure out the a value. So y is negative 2. X is 0, so just put 0 plus 3, 0 minus 5, and 0 minus 2 squared. And then we just need to clean all that up. So we have negative 2, we have 0 plus 3 is 3, 0 minus 5 is negative 5, and 0 minus 2 is negative 2, and you need to keep it squared. Then let's keep on cleaning that up. So we got a, negative 2 equals a, and then we have 3 times negative 5 times negative 2 squared, which would turn into positive 4. And then 3 times negative 5 times 4. So let's see, that would be negative 15 times 4. I'll just bring that down for the next step so you see what I'm getting. And then negative 15 times 4 would be negative 60. And then you just have to divide by that number to get a by itself. And you can certainly use your calculator to help with some of that calculating, but I just did it by hand. So then I would get 1 over 30 if I divide those by 2, and then a negative divided by a negative is a positive. So 1 over 30 is my a value. What you have to do next is just rewrite the function with that a value. Don't forget this step. Then write out your factors again, because they just told you to put it in factored form. You don't have to multiply any of that together. That is your answer. And that's it for practice quiz 6.